Hello everyone, this is lecture 5. In this lecture we talk about vectors in the plane together with lecture 6 where we talk about vectors in three-dimensional space. So more particularly in this lecture we want to look into the details of what is the vector and how could you describe a vector in the plane or two-dimensional case. And hopefully at the end of this lecture, we could be able to perform some basic vector operations, including scalar multiplications, vector additions, and vector subtractions. And we could learn how to express a vector in different forms. There are two basic forms that we're going to look at. The first one is the component form, and the second one is in terms of the unit vector forms. So first, I would like to give some definitions related to scalars and vectors. So scalar is some physical quantity that have only magnitude, whereas a vector is some physical quantity that have magnitude and directions. The example that we can include in this definition for scalar is some distance between 2 points or distance going from, let's say, home to school or distance going from school to home. The pressure that you apply on some object, if you measure the temperature around you or the temperature of the weather, that is also considered a scalar value because it just have the magnitude. For vectors, again, it's the physical quantity that have magnitude and direction. For example, velocity is an example of a vector. Acceleration is an example of a vector. Of force is also an example of a vector. So here you have velocity, acceleration, of force. So what you see here is a image of a vector. So a vector consists of 2 points. The first point is called the initial point. And the second point here is at the arrow is called terminal point. So in mathematics or in physics, usually a vector is denoted with a bold letter. But when you write on a piece of paper, it's really hard to make a letter bold. So usually you just write a letter and with an arrow on top of that letter represents a vector. Again, a vector consists of 2 points, initial point and terminal point. So, and the initial point is also called the tail. And the terminal point is also considered as the head. Okay, so that's the basic idea of a vector. Now let's graph a vector on the xy plane given the initial point 1, 1 and terminal point 8, 5. So this is 1, 1 and this is 8, 5. So the tail is 1, 1 and the head is 8, 5. And with this information, the arrowhead is at 8, 5, and that's how you plot a vector in the xy plane. Now, moving on to another topic here, combining vectors. You can perform some operations on a vector, including scalar multiplications, vector additions, and vector difference. For scalar multiplication, let's consider the vector v and the scalar k. So the scalar is just a constant, either positive or negative number. So the scalar multiplication of a vector is written as k times v. And depends on the value of k, you can have different performance on the new vectors. And you can have different behavior on the new vectors. When k is positive, k times v has the same directions as v. And when k is less than 0, you have k times v has the opposite directions as v. So in this image, given the original vector v, when you have 2 times v, that means the new vector is twice as long as the original vector, but 2 is a positive number, so the new vector has the same direction as the original one. When you have 1/2 v, now the scalar is equal to positive 1/2. You shorten or you compress the original vector to a half, but it's still pointing in the same direction as the original vector. Now, if the scalar is equal to -1, when you have a negative scalar apply on a vector, then the new vector has the opposite directions compared to the original vector. Now, that is scalar multiplications. Let's move on to vector additions and vector difference. So let's say you have 2 vectors, vector v and vector w. They have to be the same side. That means they either in 2 dimensions, either they both in 2 dimensions or they both in 3 dimensions. So they have the same dimension. So v plus w is called the vector additions. And again, they have to be in the same dimensions. There are 2 methods for vector additions. The first one is called triangle method. And the second one is called parallelogram method. And the second one is called parallelogram method. So in this 2 image, they tell you the different method that you can apply for vector additions, and depends on how you place the vector, then you have a different method for vector additions. Here, the vector v, the head of the vector v is at the tail of the vector w, therefore you can apply the triangle method. Because it forms a triangle in this sense. For parallelogram method, the vector v and vector w has the same tail, so they form. And when you perform the vector additions, they kind of form in the parallelogram image. So this is parallelogram method. So these methods are for vector additions. Now when you move to vector difference, you can do v minus w. So this is vector difference. But if you notice, it's still a vector additions. You just basically perform vector additions on the opposite of one of the vector. Okay, so what do I mean by that? So v minus w is actually equal to v plus negative w. So that's the idea of vector difference. It turns out that you still perform vector additions. Okay, so now in this 2 image, you can see the resulting of a vector difference, right? So v and w, and this red arrow is for vector difference between v and w. In addition to that, you can also perform a vector additions on the opposite of vector w. So let's suppose that this is vector w, the original vector w, and here is negative w, right? So the opposite direction as the original vector. So v plus negative w, because the head or the tail of negative w is at the head of v, so you perform the triangle method of vector additions, and this is what you get because it's formed a triangle. Alright, so hopefully you get some idea how to perform some vector operations, including scalar multiplications, and vector additions, and vector subtractions. Now let's move on to vector components. So when you perform this kind of operations, scalar multiplication, vector addition, vector subtractions, you need to know the components of the vector. So the vector with the initial point 0, 0, which is the origin, and the terminal point x, y can be written in a component form as v equal to x, y. The scalar x and y are called the component of v. The component of v. How could you get v equal to x, y, even though you have the initial point 0, 0 and the terminal point x, y? The idea is that you actually perform the calculations that the x component of the terminal point subtract the x component of the initial point, and for the second component, the y value of the terminal point subtract the y value of the initial point. So given a vector v with the initial point of xi, yi, and the terminal point xt, yt, then we can express v in the component form as v equal to x sub t minus xi, and the second component is y sub t minus yi. So therefore, if you go back to this definition, v is equal to x, y, even you have the initial point of 0, 0. The idea is that you do x minus 0, y minus 0. So therefore, eventually you're going to get v equal to x, y, which is a vector with the initial point 0, 0 and the terminal point x, y. And this vector v is sometimes called the position vector. From the definitions that we have at the beginning, a vector consists of directions and also the magnitude. You know the directions when you calculate the value of the component of the vector. You see the initial point and the terminal point, but what is the length of a vector, or in other words, what is the magnitude of the vector? So the next definition is going to give you the formula to calculate the length of a vector. So the length of a vector in the form, so v equal to x, y is given as, so here's the notations for the magnitude, and depends on the professor that you're talking or the textbook that you're reading. They have slightly different notations to describe the length or the magnitude of a vector, but in this course I'm going to use the double vertical line on each side of the vector to indicate the magnitude or the length of the vector. So here is the notations. So this is the notations for the length or the magnitude of a vector is equal to square root of x squared plus y squared, given that x is the first component of the vector and y is the second component of the vector. So I'm saying that there is a different, slightly different notations for the length or the magnitude. That is, sometimes you can see they use the absolute value notations to indicate the length or the magnitude. So when this is written together with a vector, is indicate the magnitude. If the absolute value go in with just a letter without the arrow on top, that is an absolute value. So hopefully you can see the difference. So now we're gonna write the definition for scalar multiplication and vector additions, but in the component forms. So given two vectors, vector v and vector w, right? So v is equal to x sub 1, y sub 1, and w is x sub 2, y sub 2. So these are the two vectors in two-dimensional plane. And k going to be a scalar or just a constant. For scalar multiplication, so when you do k times v, that means you do k times x1, y1, And this gives you a new vector of the form in the component form, and the new vector has the resulting component of k times x1 and k times y1. Now for vector additions, let's do v plus w, given that v is x1, y1, and w is x2, y2. The first component of the resulting vector is the addition between x1 and x2. So x1 plus x2, and the second component equal to y1 plus y2. So hopefully that gives you some sense of how to calculate scalar multiplications and vector additions. So in example 2, I want to quickly do a calculations of a vector v with the initial point of -3, 4 and the terminal point of 1, 2. Right, and I want to write the result in the component form. So vector v, to get vector v, you take the x value of the terminal point, subtract the x value of the initial point, so that is 1 minus -3. And for the y component, you take 2, subtract -4, and you get this to be 4, -2. So this is the vector v expressed in the component form. And for vector additions and scalar multiplication, we will get a chance to do the exercises a little bit later. But for now, let's move on to another topic.